Alright, in this video we're going to talk about completing the square and how to solve quadratics by completing the square. Alright, so in this particular case, what I've got here is I've got x squared plus 16x equals 9. And what I'm going to want to do is, in order to complete the square, is this is kind of how I want it to look. Is ideally I'm going to have nothing in front of my x squared. I will not have an a greater than 1. And I have nothing over on the left side that's a constant value, like this 9. Like if this 9 was written over here with the 16x, like how this is over here in number 3, how this negative 11 is there, I would want to rearrange it so that negative 11 comes over here to this side and makes it a positive 11 instead. I want it to be just the x squared and the x term over on the left. And once I have it like that, then what I'm going to do is I'm going to follow the rule that I'm going to go ahead and figure out what b divided by 2 and then square that value is. And that's what I'm going to need to have. So I'm going to set this up as I have x squared plus 16x, and I have some new c value that I'm looking for, a c value to replace whatever should be there so that I can make a perfect square. And what I do to one side, I also have to do the other. So if you notice, I put a blank space over here next to the 9 as well. I can't just add some number on the left and expect it to be a balanced equation without balancing it by putting the same thing over on the right as well. So here I have b divided by 2 then squared. Well, b is whatever is attached to that x value. So that's going to be 16. So in this case, I have 16 divided by 2, and then I'm going to square that number. Well, 16 divided by 2 is 8, so I have 8 squared, so that's 64. So what I'm going to do is I'm going to put 64 in the blank spaces. This is really important because if I don't remember to do this to both sides, and I forget over here on this right-hand side, my whole entire problem is going to become wrong because I've just done everything on the left could be correct, but without having that 64 on the right, it's completely wrong. So now what I'm going to do after adding those 64 in there, what I'm going to do now is I'm going to set it up where I have a parentheses like this, and it's squared. So this is my perfect square. I have a number times another number equals whatever is over here. So 9 plus 64 gets me 73. On the inside of this, my perfect square. So I take whatever that value is that's over here that's squared, so in this case x squared, and I just write whatever that variable is. And then what goes right here is whatever b divided by 2 was. And in this case, that's just 8. b divided by 2, it's just 16 divided by 2. And that's what I'm going to take, and I'm going to put it right here. So really what I'm saying is whatever number I solve and get x to be equal to it, that's going to end up equaling 73, truly. So what I've got to do here in order to actually solve this problem is now I have to go ahead and square root both sides. So now I have x plus 8 equals plus or minus the square root of 73. Remember, whenever you take the square root and we're finding out whatever that value is, there's a positive and a negative value. I cannot reduce the square root of 73, so I just leave it like that. And so now what I'm going to do is I'm just going to solve. And that means I'm going to bring 8 over to this side over here. And that's going to leave me with x equals negative 8 plus or minus the square root of 73. And I'm done. Again, I can check my answer if I want to. So in order to do that, what I would just do is I would actually plug in negative 8 plus square root 73 everywhere there's an x. So let's try it. So instead of x squared, I'm going to do negative 8 plus the square root of 73. I'm going to close that parenthesis, and that's squared, plus 16 times, again, negative 8 plus the square root of 73. And that should equal 9, because that's what this equation says. It says x squared plus 16x equals 9. And I got rid of x, and I replaced x with negative 8 plus the square root of 73. Sure enough, it equals 9. I can do the exact same thing. Instead of negative 8 plus square root of 73, I'm going to do negative 8 minus the square root of 73. Do the exact same thing. For the sake of time, I'm just going to bring that down, and I'm going to modify this. Instead of having it be plus, I'm going to make that minus. And I'm going to do the exact same thing over here, because it takes too long to type the whole thing in. There we go. And sure enough, it equals 9. So we just solved that problem. We checked our answer. Let's try a little bit more of a challenging problem. So right here, I've got 3x squared minus 12x minus 9 equals. So what I have to know is that when I'm doing this, I cannot do anything for completing the square if my a is not equal to 1. So what I must do is I must get this equal to, or having my a equal to 1. So what I'm going to go ahead and do, and I'm going to look at the whole thing and go, okay, is there anything that I can evenly divide out here on the left? Well, sure enough, I can evenly divide out a 3. So what I'm going to do is I'm going to divide the entire equation by 3. Not just pull out a GCF, I'm just dividing the whole thing by 3. I know, it goes a little crazy right here in your brain, right? Dividing everything by 3 and reducing. I'm just making a change to it. Because if I do something to both sides, it's okay as long as I do the same thing to both sides. So what I've got here is I've got 3x squared divided by 3. That cancels out the 3, and that just leaves me with x squared. And then I've got negative 12x divided by 3. That's going to reduce down to negative 4x. And then I've got negative 9 divided by 3, and that's going to get me negative 3. And that's going to equal 0 divided by 3, which is still just 0. So now I've got something right here that I can work with. I can do completing the square with this because my a is equal to 1. So now the next step that I have is I've got to get rid of this negative 3. I've got to bring it over to the other side. So I'm going to add 3 to both sides. And I'm going to go ahead and put in my blanks that it is that I'm looking for. So I'm going to put blank here equals 0 plus 3 is 3, and I have another blank over here. So now I've got that, and what I've got to figure out is what's going to go inside that blank. So in this case, I've got negative 4 divided by 2, then squared. Remember, it's b divided by 2, then squared. So negative 4 divided by 2 is negative 2, and negative 2 squared is just positive 4. So I've got positive 4 going in both of these blanks right here. And now this whole thing right here goes into a set of parentheses. And what goes in front, remember, is whatever that variable is that's squared. So it's just whatever that is as an individual. And then whatever goes right here is whatever b divided by 2 is. And in this case, b divided by 2 is negative 2. So I've got x minus 2 squared. And then over here on the right, I've got 3 plus 4, so that's just 7. So now I've got this whole thing right here, and I can go ahead and solve this by doing an inspection, and that's just square roots both sides. And that's going to get me x minus 2 equals plus or minus the square root of 7. And then in order to solve in our last step, we're just going to add 2 to both sides. And so that gets me x is equal to 2 plus or minus the square root of 7. So that's my x value that should be able to be plugged into this original equation here and get me 0. Let's try it. Let's see what happens. So I have 3, and instead of x, I've got 2 plus square root of 7, and that's squared, minus 12 times 2 plus the square root of 7, and then we've got minus 9. So this should equal 0. Look at that. It does. And the same thing, I'm going to try again, but instead of having 2 plus square root 7, I'm going to do 2 minus square root 7. So 3, 2 minus square root 7. See, it takes so long to type these in. But I'd rather take a long time and make sure it's right than not. So now we have 2 minus square root 7 minus 9. And that should equal 0. And it does. And so I've checked both of my answers on this, and they're both correct. It's kind of a little bit of an ugly answer, 2 plus or minus the square root of 7, but that's okay. It's still a number. That's exactly all that is 2 plus the square root of 7 is a number, and 2 minus the square root of 7 is another number. It's just a decimal. So that's how you do completing the square. Again, it's a bit more challenging when you have that x squared that has an a value that's not 1. So it makes it a little bit more challenging. So if you just evenly divide something out of both sides, then you should be able to get it equal to 1. If you can't get it equal to 1, then you can't use completing the square.